everyone. Dr. Nicky Hardy here. And before moving to Pequot Lakes, I was a scientist in the Department of Chemistry at Northwestern University, just north of Chicago in Illinois. But today, as a Crow Wing County Master Gardener, I am really excited to share some of the science of composting because I believe that when we have a basic understanding of the scientific processes that guide different things, it can help us do a better job of troubleshooting things when things go wrong, because really composting is a big science experiment and chances are eventually something will go wrong. So, scraps to soil. Let's start by talking about what we're going to talk about. First, we're going to cover some of the basic scientific principles of composting. Then I will present to you 3 of the major residential techniques for composting, talk about the integration of different composting techniques, and then finally we'll wrap it up with some troubleshooting, including some of my own trials and tribulations in composting. So let's get started. Compost, from landfill loser to soil superhero. I hope you're ready for some chemistry and some biology, and if you're not, don't worry. We're going on this learning adventure together. One of the most important things in any science field, I think, is making sure that people understand the basics, making sure that everyone is on the same page. So for me, that means defining some words as we go. And that way, we all know exactly what the definition of a specific word is. So let's get started. Compost. Compost is decayed organic matter used as a plant fertilizer. So then, what's organic matter? Organic matter is carbon-based material from a once living organism. So now I hope you're saying, well, what's a carbon-based material? To which I would say, elementary, my dear Watson. But really, I mean it's elemental. So what we have here are 3 structures. On the leftmost side, we have a monosaccharide. This monosaccharide is glucose. It's one of the building blocks for making carbohydrate structures. And then in the middle, we have an amino acid. Amino acids are the building blocks for proteins. And then finally, we have over on the right side, fatty acid. And this, in combination with glycerol, will make up our fats. So before we move on, we also need to define what those letters mean, right? And so C refers to carbon, O is oxygen, H is hydrogen, N is nitrogen, and that R group on the amino acid in the middle, that refers to a great number of variations for structures, and we'll touch on that more in just a couple slides. But before we go, I do need to say that the monosaccharide that is displayed is a simplified representation. So if you look over at the hexagon on the left, what you'll see is a little bit more information. And we use those simplified figures because it makes it a little bit easier to see, but you also need to understand that at each one of those points in that hexagon, that actually refers to a carbon molecule, and that some of the extra hydrogens have been left off, and that's just to make it so that it isn't visually confusing. Of course, I wouldn't expect anyone necessarily to remember what any of these structures are. I present them so that people have a better understanding of the different processes and where some of the gases come from, and we'll cover that in just a couple slides. So if there is any message that I hope each of you take away from this presentation, it's that all composting techniques are microbial driven. And so in the background of this slide, you'll see this really great diversity of microbes. So some of the smallest ones are going to be bacteria. Some of the larger ones are going to be the yeast. And then there's some that kind of look like they're stretching, especially over on the right side. Those are probably filamentous bacteria. But the big thing is that there's a great mix of microbes that are at work in all of the different varieties of composting. So let's talk about why your peels deserve better. Why should anyone compost, right? Well, compost enriches the soil and it also supports plant growth. And composting connects us to natural cycles. And so in food waste, when we send our food off to a landfill, we are basically getting rid of all of those nutrients and putting them in a landfill, right? That's not a very good way to recycle. We also can help improve biodiversity of our soil, and that's especially important for our microbe biodiversity because those microbes are doing incredible work. They're the ones that are involved in nitrogen fixation, so taking unusable nitrogen from the atmosphere and making it into a usable form that plants can use. And they also do an incredible job of combating pathogenic microbes. So, one example would be like tomato blight. Having a really diverse microbial population in your soil could help offsets the amount of damage that your plants end up sustaining from different organisms that are pathogenic in your soil. So the process is that we have this organic material and then we start to degrade it, and that is what our compost is. Compost is partially degraded, but it's not in its final form yet. What we really want to get to is humus, and humus is our final product. It's fully degraded and it is an exceptional growth material. Humus helps improve soil structure. It also helps with water retention and nutrient bioavailability for our plants. And then just as like another perk is I know that when I do good work, I feel good about it. And so any type of food waste that I can divert from going to the landfill, I feel really good about that. And if I can reuse it in a proper way where, it helps sustain my own personal vegetable garden, then I feel exceptionally good about that. And those are is the same type of value that I'm trying to instill in my little boys. Which leads us to reducing landfill waste. That is one of the major perks of composting. According to the USDA, approximately 30 to 40% of our entire food supply is wasted each year, and part of that has to do with restaurants and retail. So the laws that we have in place about the sale of food as it expires, right? And then we also have the residential side of things as well. And so ultimately, we have a very large proportion of our food supply that is just going straight to the landfill. And related to that is the reduction of greenhouse gas emissions, specifically methane, which leads us to our first detour, the greenhouse gases. So greenhouse gases are something that many people have heard of, but maybe they don't completely understand. So our greenhouse gases include the gases like carbon dioxide, or CO2, methane, CH4, nitrous oxide, N2O, as well as our fluorinated gases, including the hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen difluoride. And just as a little side note, I have this in pink, CFCs, because when we start talking about the fluorinated gases, the one that comes to mind for a lot of people, including a lot of people in my generation and older, are the CFCs, which were attributed to ozone loss, so ozone layer loss resulting in the big ozone hole. Side note, that is in repair since the widespread regulations that ended up in place, though not globally yet. So there's still some work to be done on that front too. And in doing all of this, we also have a couple of new elements, which are S for sulfur and F for fluorine. But we really need to kind of acknowledge that not all gases are created equal. And so for that, we have what's called the global warming potential. And this refers to the ability of a gas to trap heat relative to another gas, such as carbon dioxide, over a specific time period, such as 100 years. That's kind of the standard. So what we have here is methane, CH4, has 28 times the trapping capacity as carbon dioxide. Nitrous oxide and the fluorinated gases are much higher. So you might say, well, why are we even talking about methane when there are far worse offenders? And I would say, well, methane is part of our food story. Nitrous oxide and the fluorinated gases are not. So over on the left side with our greenhouse gases, you'll notice that carbon dioxide, methane, and nitrous oxide are all highlighted in green, meaning that there is some, they are in our atmosphere naturally to a certain degree. whereas the fluorinated gases that are highlighted in red are primarily the result of industrial processes. So let's talk about methane in the United States in 22. Our biggest producer of methane was enteric fermentation, and that is a natural digestive process by ruminant animals like cows, sheep, goat, as well as deer and other relatives. The second was natural gas, and that includes both commercial and residential gas usage. And then third is landfills, and this is where I really feel like we can quickly do some serious good. And so, what is incredibly promising is that since the 1990s, when these types of things have been recorded, we are already headed in a good direction. You can see with that big bold purple line that methane production is dropping. However, I argue that just a little bit of improvement, though awesome, there's still room for some serious improvement. So, landfills are where bad food goes to pass gas. And so now we have a new vocabulary word, putrefy or putrefaction, and that refers to the process of decaying and rot and producing a foul smell. That foul smell is attributed to gases including methane, hydrogen sulfide or H2S, which is the rotten egg smell, ammonia or NH3, as well as the amine gases including methylamine. So here we have some amino acids. So over on the leftmost side, we have just a representative amino acid. You can see that R group. And then in the middle, we have the amino acid cysteine. And over on the right, we have methionine. Cysteine and methionine are both sulfur-containing amino acids, which can contribute to the production of hydrogen sulfide. All of the amino acids can contribute to the production of ammonia by the decarboxylation of the COOH group. And so that's kind of highlighted in the orangish color. And then the production of methylamine gas, and that's kind of highlighted in that big blue box. And then putrefaction also results in slime. So disgusting, not really a big story to go along with it, but it is worth mentioning. In traditional composting, putrefaction happens when there is not enough oxygen and we move from aerobic composting, which means with oxygen, to uncontrolled anaerobic conditions, anaerobic meaning without oxygen, or if the pile becomes too wet or compacted. And when we think about that, it should make sense. If you add too much water to a pile, you're effectively moving all of the air out of the pile and replacing it with water molecules. Same story as if the compost pile is just too dense, it's too compressed, you're forcing all of the air out. If there's not air, the microbes that are aerobic, microbes, the ones that want oxygen, can't do their job. And instead, you get some of the microbes that don't like oxygen doing a different job. And it could also be a result of an imbalance. So if we have too much nitrogen-rich food, which is generally referred to as greens, this includes things like food scraps, or fresh cut grass, or if you're plant tops, those types of things, all of those are considered greens, and too low of a carbon source. And we'll touch on those carbon sources in just a slide. And the ratio that we kind of want is 25 carbon to 1 nitrogen. And it seems like a lot. It is a lot, but that is what we need in a traditional compost pile. And so when I said nitrogen rich, I hope you go, oh, that's familiar, because it should be. Here we have proteins. And so we'll go back to that amino acid over there on the right. Take a look over on the left side of that structure. You'll see we have that NH2. So any of our food scraps that are going into the compost pile that is green is generally considered nitrogen rich because they do have proteins. And that may not make complete and utter sense, but anything that is growing is growing with proteins. And contrast that to like fallen leaves. Our fallen leaves are actually brown. It's an easy easy thing to see, right? And in those instances, the primary macromolecule is structural carbohydrates, which are far easier to digest, but we'll touch on that in just a couple slides too. And so, putrefaction is like a gross cousin to composting. And putrefaction versus decomposition, it's really just a fine line. It's dependent on the bacteria, fungi, and enzymes that are present. So bacteria and fungi can both produce enzymes and secrete them. Enzymes are proteins that speed up a process. And so these enzymes could break down our carbohydrates into monosaccharides and disaccharides. They could be the proteins that are involved in breaking down proteins into amino acids, or they could be the proteins that are involved in breaking down fats into fatty acids and glycerol. Putrefaction and decomposition is also dependent on the chemical structure of the organic material. So proteins or fats are really challenging to break down. Carbohydrates are easier to degrade, and a lot of that is structural based. And so before we move on to the decomposition reactions, I have a personal challenge for you. I want you to find a saltine cracker. Go ahead, eat it, put it in your mouth, and chew, and chew, and chew, and chew. And what was once, just a starchy flavor, right, will eventually become sweet. And that is an indicator of the first digestive processes that take place with human beings. And that's the secretion of amylase in our saliva. Amylase breaks down amylose, which is a plant starch, into its simple sugars, including our monosaccharides, which generally come off as sweet. So decompositions, all of them that we are interested in today start with hydrolysis. And so here's another word that we need to break down. Hydro refers to water. Lysis is to break. And so what we are interested in is the hydrolysis of macromolecules into their building blocks. So like I just mentioned, that means we're trying to break down complex carbohydrates into monosaccharides and disaccharides, proteins into amino acids, and our lipids or fats into our fatty acids and glycerol. I'm kind of a visual person sometimes, and so here I've included what that reaction might look like. So here we have maltose. It's a disaccharide composed of 2 glucose molecules. We in red have water, or H2O, and what we'll watch is the breaking of that glycosidic bond, and you'll see that O goes, the original O that formed the bond will go over to the glucose over on the left side, and we have the breaking of the water molecule so that there's an H there, and then an OH or a hydroxyl over on the glucose on the right side. So that's kind of what that type of reaction looks like. So what we have is the addition of water and the breaking of something that is more complex into its little subunits. So the rate of hydrolysis, so how quickly water can break things down, is dependent on the accessibility of bonds. So if water can't get into a bond to break it, then water can't break it, right? And so that'll really slow down the whole process, as well as the presence of enzymes. Now remember that enzymes are proteins that help speed up a process. So if enzymes are present and there is accessibility to the bond, then hydrolysis has a really quick rate of action, and so it can really break down things quickly. And so here we have some of the complex carbohydrates from plants. Up on the top we have amylose, and you'll see that this is just a really straight chain of glucose, or not of glucose, of monosaccharides. And then we have amylopectin, which is also a plant starch. This one is branched, and so now you're going to have to try and use kind of your imagination. This is a 3D structure put on a 2D plane, and so imagine that those branches are coming out towards you and away from you. Amylopectin is a bit more complex than amylose. And then last we have cellulose, and cellulose is a structural carbohydrate. And it is actually one of the carbohydrates that make up the bulk of our brown material. Cellulose is slow to degrade because those chains are so tightly packed that it really prevents water from being able to get in and access those bonds to break that down. So cellulose is going to be one of the most challenging to break down, then amylopectin, and then the easiest will be amylose. All right, so that's carbohydrates. Let's move on to proteins. Proteins are more challenging, and that has a lot to do with the fact that there are 20 complex amino acid structures. So here on this slide, you'll see that there are a great variety of different side chains. So all of these side chains that are highlighted in blue take the place of that little r in our amino acid structure. And there are 20 common amino acids plus the non-canonical amino acids. And each of these amino acids have different properties and behaviors towards water. And as a scientist, we refer to this as hydrophobicity. And so the ability to hydro, once again, water, phobic, meaning fear of or away from, right? And so some of these hydrophobic amino acids, such as phenylalanine, which is down in the right column, bottom row, left structure, it has that big ring shape. That's a hydrophobic amino acid. It doesn't want to interact with water, and it will do so in a string of amino acids by folding towards other hydrophobic amino acids. And what we refer to that is folding. And so proteins are folded. So up at the top of this new figure here, we have a whole bunch of little spheres, and those little spheres represent each individual amino acid. Those amino acids interact with one another to influence protein folding. So we have a beta pleated sheet over on the left side, and then an alpha helix over on the right side. And then those structures can actually interact with one another to influence what's called tertiary structure, and that's when the protein actually folds. And then at the very bottom of that new figure, we have two different colors, and I do believe that it's actually four subunits, and proteins can interact with one another. And so if you can imagine the challenges of putting a water molecule into the deepest nooks and crannies of that particular protein, it's going to be hard. And so hydrolysis is going to be slowed down. It's going to have to work from the outside in, unless, of course, you have some enzymes present. So now if you thought that proteins are bad, fats are worse. What we have here are 4 different examples of some of the more common fats. So up in the top left corner, we have a fully saturated fatty acid, meaning that every single carbon has a single or has 4 single bonds. And then below that, we have a monounsaturated fatty acid, and you'll notice that there's 2 carbons that are highlighted in green, and those have a equal sign, which represents a double bond. And then over on the right column, we have 2 different examples of polyunsaturated fats. And so unsaturated refers to the presence of those double bonds. Saturated means everything is a single bond. Regardless of if it is a saturated or unsaturated fatty acid, those long tails are referred to as hydrocarbon tails. And they're referred to as hydrocarbon tails because they're made up of carbon and hydrogen, hydrocarbon. And those long hydrocarbon tails are intensely hydrophobic, meaning that they are repelling water. And this makes sense because, if we remember, oil and water just don't mix unless there's additional input, like some sort of emulsification agent like a salt or an enzyme like a lipase. So to recap, food waste is a significant problem, and foods that are sent to landfills putrefy where they can release greenhouse gases, including methane. Compostability is dependent on the macromolecular structure of the food scraps, including carbohydrates, proteins, and fats. And a great number of foods have very limited compostability in traditional systems, including animal products and things that are very acidic. So the question is what can we do? And I say, we compost multiple ways. So with that, we're going to move on to our techniques. So first and foremost, let's talk about one that many people are familiar with, whether or not we practice it, and that's compost heaps. So pile it on. This is traditional composting. Once again, like I said at the beginning, it is microbial driven, and so it depends on the bacteria and the fungi that are present, as well as the enzymes that are secreted. This is an aerobic process, meaning with air. So traditional composting requires some input from us, the composters, to turn the pile and make sure that that pile doesn't become compact and prevent putrefaction. And so we need to actually get out there and turn it some way or another. Traditional composting is also, it generates heat, and that heat is put off by those microbes. And that heat is really important because it helps inactivate pathogens, especially pathogenic pathogens, as well as, it helps inactivate pathogens, including pathogenic microbes. And it also helps inactivate weed seeds. And even in residential settings, what we shoot for is 130 to 160 degrees Fahrenheit. So your compost pile should be steaming. One of the limitations, though, is that it is a slow process. And we in Minnesota can only do traditional composting during part of the growing season. And that's because it takes time to get a compost heap up and running well. Also, it has limited input, and so animal products that get put in a traditional compost heap will putrefy. Acids will help or will inhibit some of the microbes that are there to break down that organic matter. And we also need to limit onions, because onions are a sulfur-rich food, and sulfur is what is part of that hydrogen sulfide gas. And so if you add onions, you're going to inhibit microbes, but you also run the risk of having a really stinky pile. And then you also want to hold off on putting starches in your pile, and that's because critters really like to eat starch. And so I don't know about you, but I don't want mice and other rodents and anything really digging in my compost pile. Starches could also offset the balance and introduce non-ideal microbes as well. And traditional composting has a heavy reliance on the 25 carbon to 1 nitrogen ratio. So let's talk about those carbon sources. So I've starred some of my personal favorite carbon sources. I really like dry leaves, shredded paper, cardboard, and paper towels. So a couple of notes. Our recycling infrastructure here in the Crow Wing County area does not handle shredded paper, making it non-recyclable. So in our setup, unless something has changed, of course, recycled paper will fall through the sorting machine. And that is the reason why it's non-recyclable. So here, I feel really good about taking my non-recyclable shredded paper out to my compost pile. And then another thing too, just another little perk with the dry leaves, is in the fall. I know it's way too late to talk about fall, right? We've covered in snow. But in the fall, try and leave those leaves. The pollinators will appreciate it, so you'll have different caterpillars and some of our other pollinator bugs. They'll take up residence in those leaves. And then in the spring, when those pollinators start coming back out and getting to work, you're going to have the perk of early pollination of your flowers or of your plants, your plant flowers, so be it your flowers or your vegetables. But you'll also have this really great source for your compost pile, because composting is a spring project, which leads us to our first consideration, which is composting is a spring activity. So make sure that you have everything ready to go and assembled as soon as the thaw starts happening. And so if you're planning on using a container, a pallet, a cinder block, or a bin, make sure that it's ready to be installed as soon as the ground thaws. Of course, if you want to throw it all in a heap somewhere, that's totally fine as well. But just remember that this is aerobic, and so it flourishes in the presence of air. So you got to go out there and you got to turn it. And as the temperature starts to rise, the more you turn it, the faster it's going to decompose. So you're going to be spreading those microbes throughout your entire heap, just really helping with that whole aerobic process, spreading of the microorganisms, and everything's going to decay pretty nicely. So once you get your bin installed and ready, then go ahead and wait for the pollinators to wake up. When you start seeing the bugs out, you can start collecting the brown material and putting it away. And that includes also not just your leaves, but also any type of overwintered stems and plant material. And so I don't mulch anything in the spring. I just go through and I put it all together and say, okay. And that's because sometimes there are some sleepyheads. And so there are some bugs that are late to rise. And I want to make sure that they have every chance to go out and do their job. I like my pollinators. I really like my bumblebees, and I don't want to do anything to disrupt them. And so if you are doing bin composting, might I implore you to keep part of your bin open so that those late to rise pollinators that may have accidentally gotten put in your bin have a way to escape. The time it takes for traditional composting can be anywhere between 2 months and several years. It just depends on how much energy you're willing to put into it. I've already mentioned, leave those fall leaves and gather in the spring. It's a great starting source for your carbon materials. You can jumpstart the whole process by adding microbes. So here is just one example. It's not any one that I necessarily endorse. It's just a really good example of compost microbes. And so you just go through and you sprinkle this across your compost pile and cover it up, wet it down, because remember, we need water, because the first step is a hydrolysis reaction, right? And so we need to make sure that we're giving our compost pile everything that it needs. And then one other consideration that you'll have to have is, what kind of bin do you want? Do you just want to put it all in a pile? Maybe you want to put it in a bin. My personal favorite is a rolling bin. So I have 3 little boys, and I have a rolling bin, and they love it because they get to help. And so my rolling bin is actually the one that is pictured here. It's a 37-gallon rolling bin. That green door slides open. I can fill it up with whatever. I can put my compost accelerator in there. I can close it back up. I can take it off that green platform and say, hey, little boys, can you go through and push my compost pile around the driveway? And they love it for now. They're young little boys. But then the last question really is what do you do at the end of the growing season? Let's say that we've cleaned up all the gardens. You still have food scraps, right? Because you can add food scraps to your compost bin. But at the end of the growing season, we'll no longer be able to add materials, because as soon as it starts to cool down, those microbes slow down. And as soon as that snow falls, you can basically count on no activity in your compost pile. So you're not going to be able to add any new materials. I mean, you could, and then they'll get started next spring. But what I say is consider indoor composting. And that brings us to our first non-traditional technique, which is bokashi fermentation, which can be referred to as pickling your peels. So this is a type of anaerobic decomposition reaction. Anaerobic referring to an, meaning without, and aerobic meaning air, meaning it is without air. So much of what we know about all of this approach has been by research that has been conducted to benefit the commercialization of methane production for energy. But that doesn't mean that we can't borrow some of those same principles in our own residential setting. So remember that putrefaction generally refers to the uncontrolled, non-collected methane production. However, in commercial settings, it could also be for the collection of methane. And what this looks like is the first step is hydrolysis, so hydro, water, lysis to break, followed by acetogenesis, so aceto referring to acid and genesis meaning creation. So we acidify those first breakdown products, and then acetogenesis. So that refers to the formation then of acetic acid from our acid products. And finally, methanogenesis. Methano referring to methane, genesis referring to creation. And remember that every type of compost technique is microbial driven. Similarly, this is also microbial driven. And so in the residential setting, though, we say we don't want the methanogenesis part because we don't want to be producing methane in our bokashi fermenters. And so we can do it a little bit differently. And bokashi fermentation in the residential setting requires the use of effective microorganisms. So these are microbes that have been pretty well characterized and combined in a certain way to do different jobs along the way. So one of the first is the lactic acid bacteria. Lactic acid bacteria might be familiar because lactobacilli are a type of lactic acid bacteria that are used in yogurt production. And these bacteria are incredible. They can process carbohydrates, proteins, and fats. They can work aerobically and anaerobically, so with air or without. And then we have the photosynthetic bacteria. These are referred to as the purple bacteria. And these produce amino acids, nucleic acids, sugars, enzymes for the lactic acid bacteria, as well as for the yeasts. And the yeasts are different. They're not a type of bacteria. They're a type of fungi. And these yeasts complement bacterial activities, and they also are potent producers and secretors of enzymes. And then we have the actinomycetes, and this is another type of bacteria, and these bacteria are absolute superstars for breaking down complex macromolecular structures. So if you remember, we talked about some of the plant structures, plant carbohydrates, amylose, amylopectin, and cellulose. These ones are the absolute rock stars for cellulose breakdown. So anaerobic, an, without, aerobic, air. Without air. That means that you need an airtight bin. Absolutely 100% airtight. And then the last thing that you're going to need is bokashi bran. And bokashi bran is a specialty product that's made up of some sort of starch. So this could be spent wheats or barley, for instance. It could be, or rice husks, and then it combines with a sugar. Often that's molasses. You mix it with some water. Make sure that that is fluoride-free water because we don't want to produce any of the fluoride gases. And then EM1, and EM1 is a product that you will have to purchase. Those are the effective microbes. And the bokashi bran itself, however, could be homemade using all of those ingredients in certain amounts, or it could be purchased. I myself purchased it because I've mentioned a couple times I've got kids. I don't have time for that in my life right now. So this is kind of what the bokashi bin is going to end up looking like. So first step is to go ahead and assemble your bin. Whoops. And then you're going to add your bran and your carbon. And so that is down here at the bottom of the bin. And so you'll see our bin has a spigot. That's to get rid of any of the fluids. And then there's this platform. And then there's this bran and carbon layer. And so for me, what that looks like is I take shredded paper. I wet it down, I wring it out so that it feels like a damp sponge, and then I set it on top of the platform. And then I sprinkle my bokashi bran over top of that, and then I'm ready for my first layer. And so the next step then is to add your bran and your puree, or if you don't want to puree your food, you can totally just throw your scraps in there. I personally puree all of my composted material because pureeing your food will help increase the surface area of your different food particles, making it easier for the microbes to do their job. And then you add that, and then you need some sort of press, and you press out the air from your different layers. And that's also a really important reason why I puree my food. It's a lot easier to compact when you don't have, funky shapes in there. And so you can push out all of the air really simply with very little effort when you're working with purees. And then the next step is really important. You have to actually go in and clean up any type of slop on the sides or along the lid. Along the lid, because you don't want anything to prevent air from getting in and out. And then along the sides, because that is, it introduces an increased likelihood for contamination, because those are going to be the first areas that do get hit with air when you do open up that lid, and you don't want to welcome any type of chance for contamination. And so what you do is you do this, maybe once a day, once every couple days, and then when your bin is finally full, then you keep it closed for 3 to 4 weeks to ferment, and then you can go through and bury the processed goods to neutralize the acids, because remember, we had the aceto and acidogenesis that was taking place. So this is pretty acidic product here. Or you can feed it directly to your worms. So before we go into that, this is my own personal setup. So I assembled my bin, I purchased my bin, and I wanted a clear bin because my first attempt at bokashi was an epic failure. I couldn't see what was going on inside the bin, and when I had contamination, I didn't see it until it was putrefied and stunk to high heaven. My first bokashi bin was a DIY as well, and it was 2 stacked 5-gallon buckets, and the buckets had, the top bucket had holes drilled into it, and then I had a screw top for that bucket. And because the buckets were opaque, I couldn't see what was taking place, and I didn't see that I had black mold that was growing in there. And so what I think had happened is that those drainage holes, I either didn't have enough, or they were too big, or they got clogged, and the tea ended up backing up. So that's the stuff that is produced in this process that you want to get out of there. And what ended up is, as that built up, I had putrefaction. And what I ended up doing was taking my bucket deep into the woods. I dug a really big, deep hole, and then I put it in there, and I buried it. I left it out there. But I did take that as a learning lesson, and then I decided that I wanted to try it again. This is a really cool technique. It was worth trying again. But I wanted to do it in a bin that I could see through. Actually, I haven't yet found a bokashi bin that I can purchase that is see-through. And so I wanted to make my own so that I could see through it. And so I DIY'd my new bin as well. I used a 5-gallon transparent beverage dispenser. So you'll see kind of in that picture, there is a nozzle that I can drain the tea. And I asked my husband to design and 3D print a platform that I could then separate the composted material away from the drain and also elevate it from the tea. I started my bin using shredded paper that had been dampened and wrung out, and then I sprinkled my first layer of bokashi bran over top. Then I added my first layer of food materials, blending it first. And so what is in my first layer is primarily like coffee, orange peels, banana peels, some of our just general leftover food supply, and then sprinkled some bran over top of that, as well as pureed it with bran. So hopefully by now you might have noticed something special. And what I think one of the coolest abilities of bokashi to process is animal products. And so at the very top layer, we have our Thanksgiving turkey bones. So for this, I ended up making a turkey bone broth in our Instapot using the turkey carcass. I strained the carcass from the broth to get the bones. I cooled the bones down, and then I blended them with the bokashi bran. Now remember that the bokashi bran contains living organisms. You can't overheat them or they will die, which is the reason why you have to cool those bones down. And so far it seems like everything is working fine. We have condensation that's taking place inside that bin, which indicates that it's working. Hydrolysis, remember, it uses water. We've got heat generation. And we don't have the presence of any type of black or green molds. And so right now I am cautiously optimistic that everything is going really well. Oh, and then when my bin is finally full, I'll wait the 3 to 4 weeks for the fermentation to take place, in which, we'll probably end up having to put some of our food scraps back into the landfill, because I don't want to start multiple bins until I know for sure that this is something that is going to work in our lifestyle. But once it is done fermenting, then I will end up feeding it to the worms. And that leads us to our next major technique, and that's vermiculture. So, play, worms play, work, worms work. In my house, we really like Dr. Seuss, so this is a play on Go Dogs Go. So, vermiculture, it is a combination technique. So, this is traditional composting in the heap sense, but it also introduces worms. And worms are really, really cool because they have a distinct set of microbes within their guts that do some really incredible things. But not just any worms will do. So you can't just go out into your backyard, dig a hole, grab the worms, because different worms do different things. The worms that you are looking for are in the Icenia family, or, well, species, family. So I use red wigglers as well as European night crawlers. I purchased mine from a reputable source online, everything that has been species identified. And introduce those into my compost bin effectively. And what's really, really neat about this approach is that worms can break down that organic waste into nutrient-rich castings or worm poop, but they also have a really unique ability to break down organopesticides and pharmaceutical products as well. So these are kind of composting superstars in a different way. Just another note on those specific worm types. The big earthworms that we dig out of our soil are better suited where they are because those are usually deeper worms. And so composting worms stay within the top 6 to 8 inches of the soil because they can't handle any type of compaction. Worms are living, breathing organisms. They need to have access to air. That's part of the reason why the worms come up after rainfall, to get out of the wet soil so that they can find some air. And yeah, composting worms are bred for that purpose, composting. All right, so let's see. The last major point is vermiculture is very well suited to be in a apartment or a classroom or homes that have limited outdoor space, because it brings this earthy smell. It's not this really disgusting hydrogen sulfide rotten egg smell. It smells like the soil does after a good rain. And so it's really quite beautiful. And in that video, what you see is my own worm bin. And so I'm going through the compost. You can see that I squeeze that soil. It has this really great texture to it. You can see my worms are busy working, but yeah, it's just overall, it's a really great composting technique. Highly recommend, especially for anyone who fishes, has kids. It's a great kid-friendly exercise. So what you need for worms are a bin. This can be plastic or wooden. It needs air holes because worms are aerobic, and also a drain. So you don't want to flood your worms. They won't live. You need some bedding. So this needs to be carbon rich. You can use newspaper, any of the black and white newspaper. Don't want to do colored. You can do shredded cardboard, or what a lot of worm vendors recommend is coconut coir. Anything that you choose needs to be delicate for worm skin, because worm skin is quite delicate. And then you need your worms. So a special note about worms: generally speaking, composting worms can eat about 25 to 50% of their body weight in food per day. So if you think you're going to be producing about a pound of food that you want to compost, you should have between 2 and 4 pounds of worms. And then you need your food scraps. Once again, I blend mine because I like to increase the surface area. It makes it easier for composting, and it makes it really easy on the worms. They do quick work of it that way. And the ideal temperature for a worm bin is 55 to 77 degrees Fahrenheit. So my mom is pretty incredible, and she made me a worm bin for my birthday in 2019 because I'm totally weird like that, and I wanted to start vermiculture. It's made out of scrap cedar, so all of this was just extras. it's heavy and it lives outside during the summer. My compost bin, it was made in 2019. It's still living. It's awesome. And it's a stacking composter. So over on this picture on the left, you'll see that there are 3 layers. There's the layer that has this door that opens, and that's to get the worm tea out. And then there's the second middle layer, and then there's this top layer. And each layer is separated with hardware cloth, and that allows the worms to migrate into the next layer as the different layers fill up. I purchased my initial worms online at that time just because I knew I wanted to get composting worms, right? But now it's actually really important that we do a good job of making sure that we're going with a reputable worm breeder, because you don't want to introduce any jumping worms into your garden. They have devastating effects and they are considered highly invasive. So be very mindful that when you get your worms, you're getting them from somebody who has a good reputation. And so what can you feed worms? You can feed worms some of the same things you can put in a traditional heap composter. Important that it's not the same that you can put in a bokashi composter. And so these include things like fresh vegetables and fruit scraps. You can do eggshells, cut flowers. I feed mine a lot of coffee. I go through a lot of coffee, and so my worms go through a lot of coffee. They also really like tea bags. For browns, I brought in a couple of 5-gallon pails of fall leaves before the snow came down. And we also use our shredded newspaper and shredded paper as well with that. And then occasionally, if I am at one of the big box garden stores, then I can pick up like a coconut coir seed starting block, and I'll give that to them from time to time as well. Do not compost any type of animal product. Chances are it's just going to putrefy and then it's going to stink. So how do we do this? Start by getting your bin. You can make this, you can buy this. There's a great variety of bins available online. I haven't seen anything locally yet, but maybe as people get excited about growing worms, we'll have a better availability locally. So then the first step is to add your bedding. So moisten it like a wrung out sponge, and then you add your worms and your scraps. And each time that you add your scraps, what you're going to do is you're going to dig a hole underneath the bedding, add the scraps, and then cover it back up. And then you'll just have to go and check on it from time to time. If you've got a plastic bin, you're going to have to go through and empty the tea. If it lives outside, I just kind of ignore it. And that tea is just going to pass right on through. I go through and I emptied the tea. That way I can get my worms out of there, because occasionally they'll go all the way down to the bottom instead. And then harvest your finished compost in 2 to 3 months. And when you're in a stacking tower, that allows for enough time to have your worms not only finish composting that bottom area, but also migrate up to the next layer. And worms are worms. They will produce new worms. And so different species have different rates and different number of worms that they then produce. But if you wait that full 2 to 3 months, then you're basically guaranteeing that you have enough time to allow your worms, your baby worms, all to move into the next layer. So now we're going on one more detour. Hopefully you're excited to try something new, but if you think to yourself, holy smokes, I'm not quite ready for this, know that you can still make an impact. And this is not quite composting. This is food recycling, and this is an electric process. So we use energy from electricity to break down our foods. And this is a process that uses high temperature to desiccate the food, so dehydrate, remove the water, and then neutralize the pathogens. And then it also grinds to a coarse texture. So there's a blade in there that'll take all the water out and then grind the food down. One of the perks is that it is really easy to use. You can use it year round, and it takes similar food input to bokashi. However, you have to be careful on your bones. From what I've seen on some of these that are available, they say no bones or fish bones only. Fish bones are a little bit different than like our turkey bones, for instance. However, it is a form of incomplete decomposition. So not even to the point of composting, because we're not breaking down our carbohydrates, proteins, and fats into simple sugars, amino acids, and fatty acids, right? We're just breaking it down and neutralizing it so that it's less likely to have stuff grow on it. And so on that note, though, it does make for a really awesome source to then put into your compost pile. And the last tidbit is that there is a cost. So there's the startup cost of buying this filter. From what I've seen, most of them are a couple of $100s. And then there's the cost of electricity to run. Usually a cycle takes at least 3 hours. And then there's the cost of the filters. So these mostly use a charcoal filter, and that is to offset any type of odors that might be present in your foods. So let's briefly talk about how all of these things fit well together. So compost techniques really do play nicely with one another. I'm a big Queen fan, and when it comes to composting, I wanted it all, and so I pursued it all. What I found out is when we moved to Pequot Lakes, we had a compost pile, and what I very quickly realized is that heap composting is not for me. I didn't like having to go out there and aerate it using a pitchfork. What I found worked better for me is a tumbling bin composter. However, what I also read about and learned about was that compost piles have a limited input. You're not supposed to put hot peppers in there and orange peels and onions, just like we had already mentioned, and it takes time. And so it takes time, it takes heat, it takes effort. And so for me, a traditional heap wasn't worth it. I went through and got a rolling bin instead. And then I went through and said, okay, I want to do this during the winter. So then I got worms. I purchased mine online, and then I supplemented with some red wigglers fishing worms that were species identified. And I still had more food waste than I would have liked. And so then I got chickens. They don't play a big part in this story, but know that their droppings are excellent fertilizer when composted. Want to make sure that you're composting that. And also maybe make sure that you're using it in places that are maybe more ornamental than edible. And then my last adventure was in bokashi. And I ended up with a bokashi fermentation setup. And for this, remember, you want sauerkraut, kimchi, fermented pickles, rising bread. Those are the smells that you want. But the drawback of bokashi is that it does take a little bit of effort, especially trying to get to know the science behind bokashi, and then a fair amount of tolerance for trial and error. There's probably going to be error. You're going to have a strong gut in order to get rid of anything that has putrefied. And it requires soil incubation. You can't just throw it out on your plants because your plants will die. It's too acidic, unless, of course, you feed it to the worms, which is exactly what I do. And so just to kind of revisit some of those benefits of composting, composting makes different major nutrients like nitrogen, phosphorus, and potassium readily bioavailable. It helps with the introduction of beneficial microbes into your soil. It can also neutralize pathogens and weed seeds, and it also improves the soil structure or water retention. So if you're dealing with issues where your water is running right on through, add some compost because it'll probably get stuck for at least a little bit longer, the water that is. And then it is generally safe and gentle for all plants, as opposed to like a commercial fertilizer where you run the risk of possibly burning your plants. However, on that note, be careful with the worm tea, because the worm tea is a great liquid fertilizer, but it does need to be diluted first. And so my winter setup, this is what my winter setup looks like right now. You walk into my house, you go to my coat closet, you open it up. I got worms over on the left, I got bokashi on the right. So all of my stuff just lives right on the floor. My worm bin is on a homemade rolling dolly. My bokashi bin sits right on the floor. When it's time to empty it, I just pick it up. I walk over to the toilet. I open the drain. I let it drain. I close it back up, and I walk back and I put it in the coat closet. It's all pretty simple. It doesn't take up a lot of room, and there's absolutely no smell, which is really cool. But that leads us into the last major part of this talk. So I know that we're getting close to an hour. I thank you for bearing with me so far. Know that we're right at the tail end of this talk. So, trouble in the bin, smells, slimes, and escape artists. So, let's troubleshoot a compost heap. Nothing is happening. That's a problem. Something is supposed to be happening. And so this could be that it's maybe too dry. Remember, we need to have water for that hydrolysis reaction to take place, but not too much water. So when you reach into your compost bin, be careful, especially if it's starting to steam, and you kind of squeeze your hand like this, you want it to feel like a wrung out sponge. No matter what you're doing with any one of these steps, you kind of want it to feel the same way. And so if it's too dry, add some water. If it is too cold, try and heat it up. So with this, my recommendation is to make sure that you're in a sunny area. Sun is going to be the fastest way to heat up your compost bin. And then add a temporary tarp. And so they have black tarps for sale. Go ahead, get one of those, put it over top of your heap, attach it to either your bin in some way, shape, or form, or attach it to your heap using landscaping staples. And another thing that is worth trying is adding some of those beneficial microbes, because when you introduce microbes to the system, you're kind of getting a jump start. So you're adding a whole bunch of things that are already there, just in a really low level. But if you go through and sprinkle aggressively Compost Accelerator, chances are you're adding a lot of microbes, and that's going to get everything, all of the processes up and running very quickly. Now, if your compost heap stinks, sorry to tell you, but you've got putrefaction that's happened. So with this, go ahead and aerate your compost pile. Use your nose, try and find the offender. Chances are it's a slime ball of some sort. Get that slime ball out of there. It's up to you what you do with it. You can toss it in the trash, you can dig a hole, bury it. That's up to you. And then add some more carbon to it. You cannot go wrong adding more carbon. So find some fallen leaves, get some shredded paper, go and find some cardboard. If you don't have that, maybe head over to the recycling center, talk with one of the guys and say, hey, can I get some brown cardboard? I'm using it in my compost pile, right? And generally they're going to say, okay. Also, try and add microbes. And so when you add beneficial microbes, it can kind of offset some of those non-beneficial microbes. And then if it's incomplete, you're just trying to harvest it too early, and you'll just have to aerate and wait. Or if you say, wow, I cannot wait, I have to get this out of here right now because I know I'm not going to have time later, then you can go through and sift it and add microbes, and then the microbes will just work on everything that hasn't yet composted down. So let's troubleshoot a bokashi bin. If your bin smells, your bin is open. Your bin is not supposed to be open. That means that there's some sort of air leak, or you actually have opened your bin. If your bin smells, you have to also think about what does it smell like. So one of the first things that you should do is just empty your bokashi tea. Make sure that there's no fluid at the bottom, because the fluid does increase the likelihood for putrefaction in a way that you really don't want it, right? But if it doesn't smell like pickles or yeast, you'll have to consider, is it neutral, like it doesn't smell like anything? If that's the case, then add some more bokashi bran and just wait. But if it actually stinks, then something else is probably growing. And then you're going to have to use your eyes. So if you look inside and it's white mold, you're on the right track. But if it's black or green mold, that's a sign of contamination. And so you have a couple of choices. You can scrape that black mold out and the green mold out. Once again, doing with it what is it, that's up to you and your discretion as to what you do with the contaminant. And then you can add some more bokashi bran and then close it back up and hope that the beneficial microbes do their job. Or alternatively, just like I shared with my horror story, you can dispose of it. And with that, a reminder, open your bucket sparingly. Every time you open your bucket, you introduce a chance that your bucket becomes contaminated. And so the less you can open it between layers, the better. Remember that this is an anaerobic process, meaning without air. So let's troubleshoot a worm bin. If the bin smells, you might have too much food. Worms also need carbon in order to grow. Because remember that this is kind of a two-in-one composting effort. You've got traditional composting, microbial based, and then you also have the addition of worms. And so for that, you can just add whatever your preferred worm bedding is. If your worms are escaping, there's something wrong with your environment. So this could be that it is too wet, it's too dry. And so either way, the worms are going to try and go to some place where they're happy. Remember, delicate worm skin. Or it could be that it's too hot. If it's too hot inside your worm bin, then try and figure out if you're outside, is your worm bin in the sun? Because don't put that in the sun. That should live in a nice shady place. That way your worms have a pretty constant temperature. If it's too hot, try and figure out a way to cool your worm bin down. Also, you could have a contaminant, and so this could be some sort of irritant of some sort. So that could be capsaicin from your hot peppers. It could be citrus oils, which are very not very good for your worms, or it could be the acid that comes with citrus as well. If you've got fruit flies, here's a reminder to bury your food. That's kind of up to you then what you want to do after that. So you can get the fly sticky paper and put that on the outside of your bin, then the fruit flies will land on top. But if you can live with them because they're not in your actual kitchen, they're in your coat closet, then by all means they can just do their thing too. Slime, that's an indicator that something putrefied, just like in heap composting. So make sure that your worm bin is a little bit drier, add some more carbon material, add some more worms, because if something has putrefied, it's not composting fast enough, or it just isn't compostable in the traditional sense. And if you have too much food and not enough worms, it runs the risk of actually rotting. You could also have some sort of contamination, like, oh wow, my 3-year-old accidentally put the cheese stick in the worm bin. Gotta go in and get the cheese stick out, right? And here's a fun one that I experienced just recently. I had the case of the shrinking worms, and so I had these really nice sized worms that I had purchased. They went into my worm bin a couple months later. Fast forward, and all of a sudden all my worms are really small, and I'm like, okay, what's going on? Well, worms have carbon needs too, and they need that carbon to grow. So make sure that your carbon to nitrogen ratio, although it doesn't have to be 25:1, it does still need a significant amount of carbon. You think about where you see or find worms out in nature, generally they're underneath the leaves, right? So add the things that they like to have, and you'll have nice big chunky worms for fishing. So that kind of is a recap, or here is a recap of everything that we went through. We talked about the science of composting, 3 of the techniques: compost heaps, bokashi fermentation, and vermiculture, and then talked about the integration, and then did a little bit of troubleshooting. Usually this is where I would ask if anyone has any questions, but because this is going to be a recording and there are no questions, I do remember that I had a question about chicken poo. I compost that in a heap. It just goes through and it goes into a heap, and I leave it alone. I don't even turn it. Like I said, I'm not a huge fan of the heap fermentation. I have put it in my rolling composter. It's fine. Just make sure that you're composting your chicken poo. My chickens are also free range, so they just kind of wander and drop where they are. So that was a question about what do I do with the chicken poo. I also had a question online about coffee. So I am a big coffee drinker. I like coffee. I like the taste of coffee. I like coffee, makes me happy. I have my coffee. See? I always compost my coffee. And so coffee is generally a little on the acidic side. So I'm always very mindful of what I am putting with my coffee grounds when I am composting it. And so I try and make sure that, I've got the banana peels or something that seems like a little bit more neutral. I just go with my gut as to what might offset some of the coffee. Right now I am exclusively bokashi fermenting. And so my worms aren't getting fed. They had plenty of food when they came inside. They're fine until my bokashi fermentation bin is done. If I find that they're trying to escape because they are hungry or whatever, then I'll probably add some stuff back in. But for right now, I am putting all of my stuff in my bokashi bin. And anything that is acidic actually jumps to that second step in anaerobic fermentation. So first we had hydrolysis, then acidogenesis, and then acetogenesis, and that anything acidic already brings us to that second step, which is kind of neat. If you do have questions, you can always reach out to the Crow Wing County Master Gardeners, who will get you in touch with me. I'll be happy to share any of my experiences with composting, and take any other questions that you might have. So with that, I thank all of you for joining in on this conversation about composting. I hope that you learned something. Also, keep an eye out for the slides. So if you have science questions, it'll make a good reference to go back to. So have a great time and happy composting.